following is a presentation of the Baltimore Museum of Industry, the museum that works, celebrating Baltimore and Maryland's people, their culture, work, and inventiveness as reflected in area industry and technology. This material is supported by an NSFATE program grant 0302754. Any opinions, findings, and conclusions or recommendations expressed are those of the authors and do not necessarily reflect the views of the National Science Foundation. And now, Core Technologies, the building blocks of technology systems. Trains and boats and planes are familiar to all of us. So too are microwaves and computers and can openers. What may be unfamiliar is that all of them have a common denominator. They're technology systems created by people. Whenever human beings have been faced with needs or wants that could not be met, they've invented or improved upon existing technology systems to solve the problem. On this program, we'll look at what technology systems are, who develops them, and where they are applied. We'll also identify certain core technologies and look at the systems they've produced. A technology system is defined as a group of resources working together to solve problems and extend human capabilities. To develop a technology system, such as an automobile or a microwave oven, people use 9 core technologies or building blocks. First, mechanical technology, the production and control of motion like that of an agitator in a washing machine. Second, electrical technology, a method of producing and getting work from electrical energy like that found in a hairdryer. Number 3, electronic technology, the use of small amounts of electricity to process, store, retrieve, and communicate information, like that used in the operation of televisions and computers. Number 4, structural technology, the putting together of parts and materials to create supports, containers, shelters, and connecting devices. Bridges, airplane wings, satellite dishes, and swimming pools are some of the results. Fluid technology, the use of gases and liquids to apply force, like the pneumatic air brakes on trucks and the landing gears on airplanes. Number 6, optical technology, the production and use of light to collect information, communicate, and do work. Light bulbs, fiber optic communications, and laser-based disk storage devices, such as Blu-ray DVD systems, are examples. Number 7, thermal technology, the production and control of heat energy to do work, like that performed by refrigerators, toasters, and jet engines. Number 8, biotechnology, the use of biological organisms to achieve desired outcomes. The stain-eating enzymes found in detergents and the alteration of plant genes to produce better crops illustrate some of these desirable outcomes. And number 9, materials technology, the production, alteration, and combination of materials like that found in the manufacturing of paper and the derivation of aluminum from bauxite ore. An understanding of the core technologies makes it possible to create new technologies or to apply existing technologies to new situations. From the simplicity of a hammer to the intricacy of jet fighters, the core technologies are used to produce technology systems with a wide range of sizes and complexities. The responsibility for developing these systems lies with a team of technologists. Scientists, engineers, technicians, and craftspeople collaborate to bring an idea to life. To develop the fuselage and the wings of an airplane, for instance, the technology team would use structural technology. This core technology focuses the efforts of the team on materials and production techniques that will ensure strength and stability for the aircraft. Those very same technologies can be applied to other projects where material integrity is important. The design of a chair, for instance, applies the same structural principles as designing a cargo jet. Many, if not most, technology systems draw from a number of core technologies, which may be represented as items stored on shelves. For instance, to make a bicycle, the frame comes first, which means the first shelves to be emptied are material and structural. For pedals, sprockets, and the chain drive, the engineering team refers to mechanical technology. And to fill the tires with air, the pneumatics and fluid technology need to flow properly. Portable entertainment and communication systems, high-speed rail transportation, hybrid electric cars, modern kitchen conveniences, in fact, practically all of the conveniences of modern life depend on the understanding and application of multiple core technologies. To build what is still arguably the most complex and demanding of our technology systems ever produced requires that we practically empty the core technology shelves. The International Space Station and its supporting U.S. Space Shuttle are marvels of technology that place in orbit all of the critical operations necessary to protect and preserve human life. To maintain radio communications with Earth, for instance, electronics technology is needed. To control cabin pressure for humans, thermal technology is employed. And for the various experimental manufacturing processes aboard, biotechnology comes off the shelf. To withstand the harsh environment of space, materials technology provides the protective shield. And without mechanical technology, it wouldn't be possible to open the solar panel array. And without fluid technology, lowering the landing gear would be problematic. The technology systems employed for space exploration are indeed a larger-than-life demonstration of the significance of core technologies. An understanding of the 9 core technologies and their applications prepares students for rewarding technical careers. By drawing on the core technologies, technology education students can use materials, equipment, and their imaginations to create prototypes of everything from robots to new enabling devices for the handicapped. And with luck, those prototypes will make them the star techs of the next generation. This has been a presentation of the Baltimore Museum of Industry and the Maryland Center for Career and Technology Education.